Shalan once again. I'm back for the same topic we are going through, that is oxidation and reduction reactions. I'm back with video 3, and this time I want us to look at the calculations under the calculations of oxidation states or numbers. So we are going to have some good number of examples to help us understand this better. Here, we shall have some examples. Example 1, let's start by calculating. Let's talk of calculate the overall oxidation state of calcium chloride. Remember, these answers or responses to such items have steps. For these calculations, your step 1 your step 1 should always be writing the chemical formula. So of what? Of the compound. So the compound we have is calcium chloride. So the formula of calcium chloride, calcium has a valence of 2 and the chloride has a valence of 1. So it will always result into a formula of this kind. Your step 2 is allocating oxidation states for each atom. We shall find that the calcium has an oxidation state of 2, and we saw that the chloride of positive 2, and the chloride has an oxidation state of -1. Why -1? Because every chlorine atom in its electronic configuration, it has 7 electrons on the outermost energy level. So it always needs 1 electron from any atom it is going to bond with to become stable. A stable structure of an atom is one that has the maximum number of electrons on the outermost energy level. If an atom has 1 energy level, it must possess 2 electrons on it. If an atom has more than 1 energy level, the outermost should possess a maximum of 8 electrons. So for the calcium, its outermost energy level has 2 electrons, which it is ready to give out. Since giving out the 2 is more easier than gaining the 6 to make 8. That's why the metals lose electrons. They need more electrons than they have So it needs a lot of energy to gain 6 electrons than losing 2 electrons. So the next step, our step 3, is calculating or determining the overall oxidation state of the compound. How do we calculate for that? It is simple. We merely get the oxidation state, we bring back the formula. We have it, it's here. The formula is calcium chloride, which is written like that. So the oxidation state of calcium, we found it is a positive 2, multiplied by the number of atoms of calcium in the compound, which is a 1, plus the oxidation state of the chloride, it is a negative 1, times the number of chloride atoms in the compound, which is a 2, and what we shall get will be the oxidation state of the compound. So we shall have a positive 2 plus a negative 2, which is the same as a 2 minus 2, giving us a 0. So the oxidation state of that is a 0. Let's look at that of, let's determine the oxidation state of water. So determining the oxidation state of a water molecule. So we say the first step is writing a chemical formula. So the chemical formula of water is H2O. The next step is assigning. So this is a response. We are going to allocate oxidation states. Hydrogen has oxidation state of positive 1. Why? It has 1 electron it is ready to share with others. And then oxygen, this time it is not a peroxide, it is oxygen, has an oxidation state of negative 2. So this means that to calculate for the overall oxidation state, we shall have the formula rewritten, or that of water, we shall rewrite it. And we saw that hydrogen has 1 electron, it is ready to share with others. Multiplied by the number of atoms of hydrogen in the compound, which is a 2, plus the oxidation state of oxygen, which is a negative 2, times the number of oxygen atoms in the compound, which is a 1, and what we shall get will be the overall oxidation state of water. So we shall have a positive 2 plus a negative 2, which is the same as a 2 minus a 2, giving us an oxidation state, the overall oxidation state as 0. Remember, we don't end there. We have to conclude because we don't know the 0 you're getting. So go there and say, therefore, the oxidation state of calcium chloride, like for this one, is a 0. The overall oxidation state of water is 0. Don't forget to conclude. Don't end on the answer. Please conclude. So let us look at example 3. This time, we are going to look for specific oxidation states of atoms in a compound. For example, example 4. Is it 4? 3? Example 3. Determine the oxidation state of sulfur in sulfuric acid. We are going to look for specific oxidation states of specific atoms in a compound this time. We have to bring back the other principles for these calculations to be better. Here, as usual, we have to give the formula of the compound first. The compound we have here is sulfuric acid, which we write as H2SO4. That is sulfuric acid. The next step is allocating the oxidation states. So we have that of hydrogen. Hydrogen has an oxidation state of what? A positive 1. Do we have that of sulfur? No. So we shall make sure we let any unknown to represent the oxidation state of the one we don't know, or the one they are asking in a compound. Let, for example, A, small a, represent the oxidation state of sulfur. And do we have that of oxygen? Yes. Which has what? Oxygen. We remember it has an oxidation state of -2 in a combined state. Has oxidation state of -2. But remember, the overall oxidation state of any compound is always 0. We said the overall oxidation state of any compound is a what? Is a 0. So this means the sum of the oxidation states of these ones in a compound will sum to a 0. So this means that what is the oxidation state of hydrogen? It is a positive 1 multiplied by the number of atoms of hydrogen, which is a 2, plus what is the oxidation state of sulfur? We don't know it to be abbreviated as A. How many atoms of sulfur do we have? 1, plus that of oxygen, which is a -2, times the number of atoms, which is a 4, giving us a 0. So we shall have a positive 2 plus A plus -8, giving us a 0. So we shall let's correct the terms. Our A will be a 2. No, our A plus a 2 minus 8 will be a 0. So this will give us A minus 6. When we place this on a calculator, we shall get that equaling to a 0. So when we correct like terms, when this one comes the other side, we shall remain with A as positive 6. And we said A is representing the oxidation state of sulfur, which was asked in the question. So we shall come and say, therefore, the oxidation state of sulfur is positive 6. Let me think the things are simpler now. Let me ask for example 4. Example 4. What is the oxidation state of nitrogen in a nitrate ion? Yes, we've said the first step is writing a correct formula. That is the first step. A nitrate ion is written as capital N, capital O, 3 minus. That is the formula of a nitrate ion. We said the next step is allocating the oxidation states of each of the atoms in the compound. They're asking for the oxidation state of nitrogen in the question. So shall make it an unknown. So for example, shall say, let X represent oxidation state of nitrogen. And we know that of oxygen. Oxygen has oxidation state as -2. Do we have an overall oxidation state in this one? Overall oxidation state is what? We said for ions, the overall oxidation state becomes its charge. This is an ion. So the overall oxidation state for a nitrate ion is a -1. I think now the calculation is simple. We can do it. Members, don't forget to conclude. Don't end there. They didn't say anything. In the task or the question we said, there's nothing like A. So you should conclude to link your answer or your A to the question. Here we shall rewrite the formula. We shall have the nitrate ion of that kind, giving us the overall oxidation state as -1. So we have the oxidation state of nitrogen in this question. We said it is going to be X times the number of nitrogen atoms, which is 1, plus the oxidation state of oxygen, which is -2 times the number of atoms, which is 3, giving us a -1. So we shall have X plus -6, giving us a -1. So this is the same as X minus 6, equivalent to -1. Giving us our X as -1 plus 6, such that our oxidation state of nitrogen is a +5. Members, the charge on the number of electrons lost or gained is important. So the oxidation state of nitrogen in this nitrate ion is a +5. Let me think we are flowing. Let me give the last example, and it is example 5. Calculate the oxidation state of sulfur. Remember, they can ask for anything of sulfur in ethiosulfate ion. Remember, like we've been saying that we read the correct formula of the compound first. Ethiosulfate ion is written as capital S 2, capital O 3, 2 minus. And since they're asking for the oxidation state of sulfur, we shall let it. So we shall say, let the oxidation state of sulfur be, let's call it B. And oxygen, we know it has oxidation state of -2 because it's not a peroxide here. This will imply that and the overall oxidation state of the thiosulfate ion is what? Is its charge, which is a -2. So to calculate, we shall have the sum of the atoms in a thiosulfate ion will be equivalent to its charge, which is a -2. So our oxidation state of sulfur, which is we abbreviated as a B, multiplied by the number of atoms, which is a 2, plus the oxidation state of oxygen, which is a -2, times the number of atoms of oxygen, which is a 3, will give us a -2. So the 2B plus -6 will give us a -2, which is a 2B minus 6, giving us a -2, such that our 2B is -2 plus 6, giving us a 2B equivalent to a +4 by 2 by 2. A 2 goes into a 2 once, such that our B is a +2. So the oxidation state of sulfur in a thiosulfate ion is a +2. Don't end here, conclude. Members, I think with these examples, we've at least tried to simplify the concept of oxidation states and numbers. We said I'm taught online. This is the 3rd video about this topic of oxidation and reduction reactions. I will remain Teacher Alan. Don't forget to subscribe, to comment so that we can improve our services, to like and share if you really like others also to benefit, if you do benefit. Thank you.